PIC16 F84A microcontroller, I was able to control two DC motors. The directions were controlled by various switches, as well as an auto run routine, which was controlled by a fifth switch. To do so, I connected my DC motors to my port A and set up my port A to function as outputs. To do this, I first had to clear my corresponding TRIS A bits, which allowed for my port A bits to be corresponding output bits. The next step was to set up my port B as inputs. I only needed 4 of the bits to be inputs, so I only set the first 4 bits. So RB0 to RB3 would function as my input switches. I've made a little comment here just so that way I wouldn't forget which bits were connected to which motor. So for RA1 and RA0, those controlled my right motor, and RA2 and RA3 controlled my left motor. So that way in my monitor subroutine, all of my switches would be continuously monitored, and depending on which switch was tripped, it would choose the designated subroutine to go to or to call. For instance, had the first switch been tripped, this would cause my microcontroller to call my right motor forward subroutine located here. This would clear the desired bit connected to the right motor, which was RA0, and it would set the desired port A bit, which was RA1. This caused the DC motor to move in a clockwise rotation. Had instead my RB1 or my second switch been tripped, it would have gone to my right motor reverse routine, which would do the opposite of what my right motor forward routine would do. This instead cleared my port A RA1 bit, and it set my port A RA0 bit. If an event happened where the first 2 switches were on at the same time, it would clear each bit before setting the following bit. This prevents a short from occurring, which would damage one of the transistors on the board. The way in which the left motor worked was the same manner, except it would set port A's RA2 bit and clear port A's RA3 bit for forward, and set port A's RA3 bit, it would clear RA3 bit and RA, and it would set RA's second bit in order to go in reverse. The fifth switch was used to run a pre-designed or a predetermined path, which I programmed in. So if the switch connected to RB4 was tripped, it would go into my autopilot subroutine. My autopilot subroutine would first set up my timer 0 to act as a timer, which was used in conjunction with a counter in order to determine how long the robot would move forward, turn right, and turn left, and continue to move forward. To do this, I chose an internal instruction cycle for my timer and assigned my prescalers to my timer 0. Because I was using it to determine how long my robot would go forward, I chose the highest prescaler, which was a 1:2:6 ratio. And then I set it up as an interrupt, so that way upon overflowing of my timer 0, it would jump to my interrupt service routine located at OX004. My interrupt service routine is to be seen here. The first step was to save my working register contents, and then save my status register contents so that upon returning to which the interrupt occurred, the program could continue as normal. But the sole purpose of the interrupt service routine was to just increment a counter, which was used to determine whether or not my robot had moved forward enough. by moving this counter into my working register after incrementation, I could exclusive OR with a desired count, which once reached would cause the Z bit in my status register to be raised. Once it was raised, it would next go to the write routine located here. Once in the autopilot write routine, the robot would turn right fairly quickly, just enough time to cause it to change direction. And as my timer 0 continued counting, once it hit 70, it would jump back into interrupt service routine, increment to 70, by Z bit would be raised by exclusive OR and continue to move forward. So that would put it here. Once my counter reached its limit, it would jump into my turn left subroutine. And because the count had already reached its limit, it would start back at 0. So by counting up to 30 hex, I could cause the robot to turn left. Now, depending on the status of my autopilot switch, it would either go back to the monitoring or it would continue in this autopilot subroutine. And that's how I got my robot to do various things.